Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. My name is Dan Scofield. I teach science at St. Bernard's Academy.
And I'm Ken Pinkerton. I'm a retired science teacher from Zane Middle School in Eureka.
So welcome to Homework Hotline. If you want to answer some science and math questions, get some answers for science and math questions, please go to homeworkhotline.tv and click on, there's a couple choices. Click on the link for the live feed. You can also click on another link to send us an email with your question. And it will show. The new technology here is going to show pretty amazing up here.
True.
And so go try that.
Yes, definitely do. So, in the meantime, reminders, or just to let you know, the Humboldt Math Festival is coming up in April, on April 4th, and it's a community celebration of math. It's free, and it's completely organized by local teachers and students. And so, if you're interested in math, go to the website, which is humboldtmathfestival.org. And you can get a hold of me or other people that are involved and do it.
That's April 4th. And then about a month before that, we'll have the Humboldt County Science Fair. I know a number of maybe some viewers are working on science fair projects. So maybe you have questions about that.
Yeah, that would be great. So I know you judge every year, right?
Yes, I do.
Yeah, so I go up and help set up and take down. That's my job.
And I do whatever they tell me to do.
Right, that's true. But I know you're one of the interviewers and stuff like that. So yeah, if you have a question or want to run something by us as far as you think it's an effective way to display it or to check it out, or we'd love to hear from you. I know it's an amazing event. And also in March, we're going to be jumping in the bay. The perilous plunge that supports the Discovery Museum is coming up too. So
some of you will be doing that.
Yeah.
So
it would be good for you.
Oh, probably. Lots of things would be good for me. So last time on Tuesday, we got to a little bit of electricity. We made some electric current. We were making batteries. Talking about that. So we're talking about current is flowing. A charge that flows from one place. You have to have them hooked up from one end to the other on the terminals of a battery or from a generator or something like that. But the point is, you've got to get them to, got to get the current to flow. You can also just have an electric charge build up on something on a point source, and that's called static electricity. And so we thought we'd play around with some things with static electricity.
Yeah. So, and then static actually means to hold still. So the stadia or that root word means to hold still. Mm-hmm. And so what's neat, one of my two favorite things now are in the summertime. Watching kids go down slides.
Oh yeah, the plastic slides and their
hair stands up, and that's because of the friction. So static electricity always derives from some sort of a friction. And the other one is trampolines, where they just get these users. So a classic one is the friction of I'm rubbing balloon on my hair. And then a neat way to show charge and some of the properties, that this is just old Rice Krispies, I think, or Rice Krispies, and you can see it's a traction. And then what's neat is, so it's the old opposites attract. So what's happening is that the charge that's on the cereal is one charge, and the balloon's another, and so they'll attract. But then if you watch,
that's great. Yeah,
you'll see it'll also drop away as soon as the cereal will gain the same charge,
and they'll be repulsed.
And so then they get pulsed.
In physics we talk about this. This is the force of electrostatic force, and so it actually is one of those fundamental forces. It's the electric force, and it's dependent upon the charge, how much charge there is in each item, and how far away they are.
Right.
Actually, the formulas are very similar to gravitational force, but
isn't it squared by the
distance? This is right. It's the inverse squared relationship, and then the charges of the two objects are directly related. So you multiply the charges, and then you divide by the distance squared. And so the closer something is, the more attractive it's going to be, and also the more charge there is on each thing, the more attractive it's going to be, and you can solve problems with that if you like to do that kind of thing.
And then the applications are pretty cool. Whenever they use it for painting painting things, painting cars, where they actually put a minor charge on whatever they want to paint, and then also charge the paint with the opposite, and so the paint goes and it sticks to whatever they're trying to paint, rather than having it float in the air. If you've ever done spray paint, you know how much overspray can happen there.
Yeah, and that's not very good for you to
no,
breathe that stuff in.
and then the other application is copy machines.
Oh yeah, that's right. They actually put the ink on with the, or whatever they're using,
right,
on with the electric charge.
Electric charge, yeah, and then somehow, and then they fuse it. They have I guess it goes over an oiler, and it fuses it onto the paper. So they're So if you open up a copy machine, if you ever one, you'll notice it'll say high voltage, and that's because of somehow they develop a very high voltage, very precise, which is pretty amazing.
It is. The technology has come around in the last 20 years for for printing machines has been amazing.
So that's a simple one. So, and you probably, like we talked about on the slide. So what's happening is that when you have static electricity, one object always gives off electrons, and the other object takes them.
Right.
And so that's why it gets. If it gives it off, then it has a positive charge because it's given off a whole bunch of negative electrons. Right.
Right. The object has become positively charged, and it's taking it from objects like your hair. Will take charges from
Right.
Your hair does. My hair wasn't doing very well
good.
for some reason.
Yeah.
Another thing is that you can have the slide, going down the slide will do the same thing.
Yeah.
A lot of electrons will come off of that and onto your hair, and
Yeah.
it gets under your body, and then it all got your hair, and it sticks
Yeah.
straight on in.
Or you know the trick of rubbing your feet on some carpets.
That's right, and then
you
coming up
walk
to your favorite person and touching them.
touching them in the ear.
No, don't do that. Don't do that. Don't do that to anybody
you
you
get
like.
the most rise. That, I don't know, that's for sure.
This one is a great. You're showing me this device. This is a little fun fly stick, and I guess there's a belt in there, and the belt is rubbing up against something on the. Is it like a
I think it is just like a little wheel inside.
wheel inside? So it's rubbing up against that, and it'll generate a charge on the outside.
Right.
And
And try it with. It might even work really well on that. I don't know. I haven't tried it with that. Oh yeah, that's
you see how it's going up and going down again.
right. So that's a neat. It shows the attraction and then repulsion whenever it develops the charge.
And this is a fun one too. These little things come with it, they're like little snowflakes. But it'll touch it, and then it'll touch my arm again and go back and forth between
So
the two.
you're
of them.
grounding it out. And
Slowly
and
grabbing
it's
it. with my
attracted,
shirt.
right?
See, let's go like this. Yeah, that works pretty well. So it's touching, it's getting close to the stick, picking up a charge from it, and then being repulsed because it's the same charge, and then going to my hand, being attracted to my hand because it's the opposite charge, and then picking up the same charge from my hand again. So back and forth. We'll just do the whole show.
Well,
Do
just
this
I know it's
continuously and
fascinating,
talk. I mean, I can get.
It is, and it shows it so much of how the attraction and repulsion by.
And I'm getting a mild shock every time it touches me.
Yeah.
Nothing too bad, but this is pretty fun. And then you can go faster and then farther apart.
Right, and that shows like you said, the inverse. That's
Right.
great. You got this down.
I know what I want for Christmas.
Yeah, right. So the number one enemy of static electricity is water.
Yes.
So we took our chances today. High humidity days. So a rainy day is the very worst day.
Right. And we got a rainy day today, but
rainy
still
day,
things are
so-
working.
Yeah.
So that's this. This is kind of like a miniature Van de Graaff
Right,
generator,
which is just this guy.
Which is the big version of Van de
Right.
Graaff generator right here.
And the way they work is the same thing. There's a motor down here. Let's see if I can turn it for the cameras. So there's a motor down here that turns, and if you'll notice where my finger is, there's a belt. And then if you go up to the top, you can see as I move it back and forth, the belt goes through this tube. And then there's a tiny wire up here that is slightly spread out. And so static electricity loves sharp things.
Right.
And so that the static electricity is attracted to this.
And,
And then we get a bigger charge by putting a dome on it.
move that out of the way here.
Yeah. And then if we turn this on, we can see, or here we'll do this. So we put,
Let's start with that one.
Yeah,
That's
sorry.
great. And then
and then
and then spend some time drying this out for a little bit first.
Right.
Because that worked.
yeah, if you ever have a Van de Graaff generator, if you just happen to have one at home.
Happen to have one?
And it doesn't work on a rainy day. The trick is you take a blow dryer, a hair blow dryer, and you put it on the base near the belt, and it'll dry it out, and then you get this amazing thing. So this is neat. You can see the repulsion that's happening and the attraction. If you put your finger out, you'll see it gets attracted to it.
And it dissipates the charge.
Right, takes it away.
You can watch if I dissipate the charge just by touching the side.
Right, down there.
It drops it.
Right. And then what's neat is you can show with this, if you bring it in, like I said, static electricity likes sharp things. So of course, it's going to prove me wrong. But if I do it with my finger, it'll lose the charge. But if I bring in my fist, it doesn't lose quite as much. So that's the small one. And then I hate getting shocked. So we can do the bigger one. Well, we'll do Barbie first. So this is, and you can see, so the reason that all the hair is sticking up like that is there actually is pushing away from itself. And so every hair is being coated with electrons, and then they're pushing away from every other electron, and then so we get this wonderful display of
all the same charge again. So it's they want to, I guess. They don't really want to, but they have a tendency to push away from each other.
Right.
And even these things down here are getting
you can see the bleeding over it.
And again, if I approach it with my finger, it's attracted to my finger.
Right.
And
so you can hear it. I don't know if I won't put my microphone by it because
who knows what I would find notes. If I put my fist next to it, because my fist coming
almost nothing.
Well, I have to get pretty close to it.
Yeah.
But I put my finger at the same distance. It
takes
goes
it
right
away,
towards
definitely
it.
So. And if you look on airplanes, the backs of wings, you'll often see pointed things coming off of it, much like this, and those are to help discharge static electricity.
Anything the plane's picking
and then
up.
some on cars too. They because you have all those things rolling. Some cars will have little things that hang down on them that help dissipate the charge. So if you're in the desert, if you ever traveled in the summertime, sometimes you get out of your car and you get a heck of a shock because the car's built up friction.
Yeah, and that's one of the reasons why you're not supposed to go, if you're pumping your gas, you're not supposed to go into your car and then come back out again, especially in a dry place like that, because you can create a spark.
Right, yeah.
If you're pumping your gas, it's not, around here, I don't think it's as much of an issue, but it's one of the things you shouldn't really do is go back in your car and sit in there for a little bit and then go back out again because you... Yeah,
because even fluids, like if you have a big CO2 fire extinguisher, I've gotten a really good shock off one of those because you have all this air going by and it's all that friction against the bell. And they used to make them out of steel before they had all the cool plastics. And so if you had to be careful using a CO2 extinguisher because you could get a heck of a charge from it.
And then I guess that's one of the ways we have lightning. Too.
Yeah.
All that friction.
Yeah, the air raising up and
all the hail, the ice crystals going up and down, rubbing up against, making all that friction, and eventually the clouds build up charge in the different parts of the clouds, and between the cloud and the ground, and then you get a discharge.
You get a giant discharge. So if we can show that with this wand, which is hooked up to a ground. So that this wand is got a wire going down it, and I have it hooked up to it's really high, and so this actually goes to probably a water pipe that goes to the building. It's plugged in, and so you can see I can take away her charge. That's the best she's ever worked on a rainy day. That's amazing.
Yeah, she's doing great.
So, and again, every one of those hairs. And then back to your gasoline thing, what's really important, and it's, I see people do it all the time, is if you fill in a gas can for your chainsaw or lawnmower or something, you need to take it out and put it on the ground.
Yes.
Because the same thing, gasoline's coming out of that nozzle, and it can create a static charge. And since you're sitting on rubber tires, you can get a heck of a charge, and you get a little spark, and you're going to have a huge explosion.
Yeah.
Gasoline, especially always the vapor. So with her, you can see every one of her hairs is pushing against all the rest of them, and so we get this wonderful display.
What a great! She's my favorite one. Yeah. And then I can again bring my finger in.
Sharp things take away the static. And
and then or pull it away. Or
Right.
and of course my fist not as much.
Not so much, right?
Yeah.
And then sometimes this will do a great job of doing it, but not today. I'll just throw this away. Sure. Here, let me move this over a little bit. I'm going to turn it off first, and then we've got some other cool things to do. So, all right. So we'll put her back on, and then
Play around.
you want to do the happy? Want to try those?
Oh, the okay.
Yeah, we can do it. And then with on people too, we can do it and show you some.
Sure,
some other things. Neither one of us have long hair for
Right.
So this is a fun one. And we have this at the math festival.
You can do this.
So yeah.
Happy ears.
And then what we do is we actually use a milk crate back here.
Right.
It's plastic, and so it's a good insulator.
So I can get off the ground.
Yeah. And
So I'm gonna get a little taller here.
Yep. And then the other thing is we have Dan stand back from the table, otherwise he can get shocked. And the rule with the Van de Graaff generator, if you do this with your hair, is you can take one hand off at a time, but you can't take two off. You can, but you'll get shocked. So, and I'm going to stand away. So you can see that the little horns are starting to stick up on Dan.
Always one.
Oh, there you go. That's a good one. You can see and that's the same thing. So Dan's whole body is being coated on the outside with static electricity, and so all the little horns are little what do they call it? Aluminum strands are pushing against each other.
The icicles, or whatever you want to say.
So,
but if I touch Ken,
which you're not going to do. You want to touch the wand?
Whoops.
And then and you'll hear it crackling too, or it'll reach down and so if you.
We lost a monitor. We lost a monitor. That monitor did not like it.
That didn't. Did it go?
That I felt that pretty good.
That's a good one. So now, if you take your hand off, so Dan's still covered. You'll notice that he's got all of that there. And if he steps off, then he's grounded. The extra static electricity will go through his foot.
And hopefully
he very carefully
not touch the thing at the same time. Right now, and I'm still feeling a little charged.
But it's not quite as much.
Not quite as much. So I'm going to take this off. I don't think that's about the best shock I've gotten off of that thing. That's really going.
Yeah, today is amazing for. And then a fun thing you can do. Well, we can do a couple of them.
Yeah,
is
the pile of plates.
The pies. So, and this really illustrates the repulsion. So right now, there's no charge on those pans.
And when you think about it, if you think about it with forces, we have force of gravity going down for each pan, and then normal force going up, and they're balanced right now. So we'll get no acceleration. They won't move; they'll just stay there. But we can build up enough actual static force, electrostatic force in it that it'll change that situation.
Right.
So,
yeah.
So just by turning it on.
Okay.
Here we go.
And you said you're talking about forces in your physics class, right? So, whoop. There's a heavy one apparently.
Discharging off the pan on the ground too.
Okay. Yeah.
There we go. Well,
so here we'll try this and see if that'll help lift one.
A little more mass on that one.
Yeah, you can see that one. So somehow they're stuck together. Maybe there's some pie crust in there still.
I can feel it coming off.
Yeah, it's really a big one. Here, let's pull this one off, the top one off. Might be too heavy or something. Oops.
Oh boy, it is.
You want to do it while I take the charge away? I'll keep the wand on there so there's no charge.
Okay, here we go.
That one we can put the other ones on. We'll do a repeat. So that's because there's tape.
Oh, there's tape in the bottom. Okay, that's why.
That's why.
Okay, let's
That's
do it again.
Yeah.
Just gonna do the same thing.
We'll see. Okay. 1, 2, 3, 4, 5. All right.
Woo!
And that's because of the repulsion of the like charge. So we'll turn that one off. And then, are you the science host today, or am I?
The science person?
Because the science person always has to clean up.
I think we both have to clean up.
So
I think it looks like we might have a question.
Oh, cool.
So, okay, why does our hair have friction that can cause it to rise up like the doll? And then when I put my hand, I think, close to the doll's hair, her hair moves with his hand. I think that's basically what I think we're saying. Is that why? Okay, so why? The question is why does why does our hair have friction? Why does it? I mean, not why does our hair have friction, but why does it cause the charge to come off? Of it? And then the other question would be why does it go down? Why does it go down when I put it close?
Right.
Our hair has electrons like anything else, and electrons can move from surface to surface. I think that's the first part of it. Electrons can move from surface to surface. And so when you rub on something, then you can rub the electrons off, and then that object or whatever you become coated with something, or the object gets coated with something, and then so that object gets coated with electrons, and since the electrons are all the same charge, like charges repel, and opposite charges attract, and so also it will tend to. So why does a balloon stick to the wall then? Right. If the balloon is charged and the wall has no charge, why does that happen? And the reason why that happens is because it actually pushes the negative charges in the wall away from it, so it kind of leaves the positive charges there. It polarizes the wall actually, and so there's a part of it that's more attractive than the other part.
So with the hair, the cool thing about hair and why I like that so much is just like these plates, every one of them is absolutely coated top and bottom with extra electrons, and so we get that buildup of just coating with billions of electrons, and so they push away from each other. But hair is really lightweight, and so whenever we put that on there, it's also coated, but they also push away, and they're attached, and so they don't have any way to go besides just up and out.
Right.
And then so when Mr. Scofield puts his hands close to it, he has a negative charge, or he has a neutral charge, because he's touching the ground, and so he's actually he's actually taking some of the charge away, sometimes dramatically, and so you can see whenever he takes the charge away, it affects all the hair on the doll, so that they're no longer pushing away from each other.
I always bring this into my physics class, and it's one of my favorite days. A couple other things we can show. We don't have a lot of time left, but we can show the thing. Let's show the
light.
Let's see if we can do the light.
Okay.
And then so
this is a neon tube.
And with some lettering, right?
It was a big L.
It was a big L.
Sadly, I got there just in time
to get the L.
It was a hotel sign, and then watch out for getting that on you. And then so you can see, I'm going to try to bring this so we have a little bit of contrast.
I can see it from here, but it's actually lighting the tube up.
Yeah, so I don't know if you can see it. We've got the bright lights in here, so I don't know if the camera's picking it up, but it's actually flashing quite bright. It's got the nice neon.
I'm going to move it away for a second just so we get that big charge again. And then, here's that. Boy, it's
really popping.
It's popping off of the hair over there. Let's see what this does.
Oh, there you go. That was nice. So bring it out again. Oh, that was a good one.
Yeah.
I'm going to move this. Okay. Yeah.
So if that showed up or not. Is it?
Try the whole.
Okay, one more time.
I'll watch the monitor.
Okay. Very good.
Yeah, I can see it. Yeah, so what's happening there is the neon is being excited so much that it's giving off light. So we've got an energy transformation.
Right, the electrons are getting excited up to another energy level, and then as they go down, they emit light. So it's pretty cool. A lot of things work that way. So normally you light up a neon sign by having electricity flow through the
and really it's like 10,000 volts. It's incredibly high voltage to go through that. This is the one why I was asking which one of us has to clean up, so I guess it's both of us. So this has got old Cocoa Puffs in it, and so right now they're being totally that's
I think why I had the tape. One of them has the tape on the bottom of it for this reason. Hold on, let's
try that one. I don't know if the tape is any good anymore, but
we'll see if it's.
We got some electrical tape right here.
You got electrical tape?
Yeah.
Why would you want to use electrical tape?
It's what we got.
Okay. No, it's electricity. It's electricity, so we're going to use electrical tape. Here we go.
Okay.
Okay, here we go. Right here for now. And then.
Okay.
Making
cereal. I've got a little bit. I've got some extra over here.
Crispies. All right.
And then we'll try it.
Okay. Got it?
Got it.
And here we go.
So all the Rice Krispies are totally getting extracted, and so you can see kind of a popcorn.
More like
going up that 30. All right. So I'm Ken Pinkerton retired from Zane Middle School.
I'm Dan Scofield from St. Bernard's Academy.
Keep up the great work on your science projects. I will see you next week, and here on Homework Hotline.
Right, it'll be a few more weeks for me, but I'm looking forward to coming back again in February. And we'll see you next time.
Yeah, definitely so.
No, you get to clean this up. Right?
Yeah.